Hello, welcome back to the live stream about Kubernetes and Azure AKS and Pulumi. So in the last stream, we put together some more of our Azure Kubernetes service using Pulumi written in C#. And in this stream, we're just going to take that a step further and see if we can harden it, make it better, add more features, we'll see how far we get, because there is a lot of stuff you can add to Kubernetes and Azure AKS in particular. So let's get right into it, and I'll show you what I did between now and the previous stream. So previously we had a bunch of node settings for our Kubernetes cluster hard-coded, but I've now hooked them up to configuration. So there's an iConfiguration interface now. Well, we had that previously, but I've gone through and added loads of comments to all of the configuration options. So we have maximum surge, maximum pods. All these ones that start with Kubernetes are being plugged into this node pool configuration here, and other bits and pieces as well. And those show up in our Pulumi configuration file over here. So we can determine, we set up last stream a maintenance schedule for Azure to upgrade the Kubernetes cluster. So we're saying, any day I want you to be able to upgrade the cluster between 1 and 3 in the morning. We also allowed the maximum number of pods on a node. We allowed 33% maximum surge when you upgrade the cluster, so it will create 1/3 extra nodes using the new version of Kubernetes, and then take down the 1/3 of the old version, and then keep doing that with the second third and the third third. We got the node count. I've just got one here, but in my production YAML I have a few more. And then we had the OS disk size, 30 gigabytes. And then we also set the eviction policy on what to do when the cluster is scaling down. We haven't enabled auto scaling yet, so we'll look at that maybe in this stream. And then I stuck the VM size in here. This is just the cheapest one, the smallest VM size. So we have our kind of common settings up here, Kubernetes settings over here, and then later on we will use these container settings when it comes down to using the actual Kubernetes API that Pulumi provides us to instantiate deployments, services, ingress, all the rest of it. So let's dig right into the next steps that I had listed. So I have a list here of improvements that we can make. So the next one is around the Kubernetes version that we're using. So I actually had this comment over here. You can set the specific Kubernetes version that you're interested in. I actually think I don't want to ever have to specify that. I just want it to automatically upgrade itself. And there is some settings that you can use called Autos Upgrade Profile. And I'm just going to remove that and stick that down here. Auto upgrader profile equals new, and I'm just going to copy and paste some code here. There we go. And what this can do is you can tell it which Kubernetes version you want to auto upgrade to, and the options are, if I can control click on here and it'll wait for it to go to definition. One of the options is stable, so that is the latest minor version, the latest patch version. Or rapid is, I think it was the latest stable version, but even it does it straight away as soon as it comes out, whereas stable I think takes a while. And then you can also just manually specify a version like we did before. So I'm gonna add the upgrade channel as a configuration option. So, and that will give me a chance to show you some of the new configuration settings that I set up. So let's jump right into it. So Kubernetes, I'm going to call it Kubernetes upgrade channel, and we'll stick it in here. So this is going to come from our config file now. I'm just going to set some comments in here, and we'll just call it whoops, what am I doing? The gets the automatic upgrade channel used to upgrade the cluster. Okay, and we'll just take this and also implement that property over here. And I created some nice new shortcuts to be able to pull these settings from the configuration file, and one of them I created is called get, and what this does is, you'll see in a second, oops, what did I do? Cool. So what this does is, if you look at upgrade channel, I thought it would be an enum, but it's actually a struct, and that does actually make it more difficult to deal with, because how do you parse a struct, parse one of these upgrade channels from a string? Doesn't seem to be a way to do it. There is this private constructor, but I can't have access to that. So there's no way to parse this, and this get function just does that for me. It parses the string for me and outputs an update channel, but you do have to give it a dictionary of string and the update channel, upgrade channel, so that it can pick up which one you want. And in fact, I'm not doing this in order very well. So node image, I can't remember what node image meant. It's all in the documentation actually. None, patch, rapid, and stable. Cool. So if we have a look at this code really quick, it's just, looking up the key and pulling out the value and throwing if one is not available. Other ones I created are getting a double value, getting an integer, getting a string, and then I added some like validation parameters here. So this integer, you can provide a minimum and maximum value, same with the double. And for the string, you can provide a regex pattern. And you can also get a string collection, an integer collection, and a collection of type, an arbitrary type like the struct that we have in upgrade channel. So now I have this. I'm also going to update my test configuration implementation so that my tests still passed, and I'm just going to do that. Doesn't have to be perfect. And then finally, I'm going to set this to stable over here. And in my production YAML as well, do the same thing. So in fact, in the development one, you could probably even stick with rapid. And maybe if I quickly go to the documentation, I can remind myself what rapid meant. So if we go here, there's some options. Surge, oh no wait, that's not it. Here we go, none. Disables auto upgrades, makes sense. Patch upgrades to the latest patch version, stable. Rapid, automatically upgrade the cluster to the latest supported patch release on the latest supported minor version. And node image, automatically upgrade the node image to the latest version available. I think node image on development would make a lot of sense, because you want to test that you have, but then maybe there's an argument to say that you want the same on production as you want in development, so maybe both should be stable. Although you would maybe want something that's slightly ahead as well, so that you can test. I'll go with stable for now on both of those. We'll just check to make sure that that still works. Stable channel. We'll deploy that and check that in. Stable upgrade channel. The next thing I have is the tier. I didn't actually set this up, so if we go back to our Kubernetes cluster, there is a SKU. SKU equals new, and we'll pass that in there. What's happened here? And the SKU that we want is interesting. I can't remember what it was. Paid and free, I think. Let's go check it out. And the difference between these is interesting, because yeah, paid and free, SKU tier, and then the cluster name, I can't remember what this was for. Basic. I think it's just always basic. That's fine. SKU tier. So we want Kubernetes SKU tier as a configuration option that we want to pass. And the difference between free and basic is that free is that with the paid version your availability goes up slightly. So we want, what is that type? This guy. SKU. What do we feel here? KU, capital KU or lowercase KU, as they've done. Not really sure there. It's an acronym, so I'll go with what they've done. Gets the cluster SKU, gets the tier of the SKU, the paid tier results in higher availability. So I remember thinking it was pretty expensive to go with the paid tier. It costs like an extra £50 a month, or I guess if you translate that into dollars, it'd be about $80. But you do get higher availability from that, so it depends if that is important to you. And I'm just gonna implement this in the configuration options, so we can pass this in from our Pulumi YAML file. And I'm gonna grab that, stick that in there, and we'll just delete some of these. And we'll go with free. and paid. Cool. We'll take that, stick that in our test as well. Cool, thank you. IntelliSense, not IntelliSense, I can't remember. Visual Studio calls it different to the GitHub version, and I don't know why. And we'll go with the free one in development, and we'll go with the paid one in production. That makes the most sense to me. So then we just need to plug that in here. Oh, I forgot to plug in this guy as well. So configuration.upgrade channel here and .skew. There we go. So let's see, the deployment worked last time. So let's see if it works again. Okay. Just make sure that works, and we'll check that in. Next one. I was thinking we could go and add Autoscaler. I haven't read this documentation yet, but somewhere down here we can enable it. Enable Autoscaler. And in particular, enable Autoscaling. Oops. What do we need to add this to the agent pool profile? So I think that's as easy as enable autoscaling true. I'm not going to create a config setting for this one because I think it should just always be true. So we'll turn that on. So this will scale the number of nodes up and down based on the rules that we've set up. Some of these config settings are related to scaling, so like the max, the eviction policy. Whenever you need more pods and there's not enough space, it will scale up, and when you have free space on your node, it will scale down using this eviction policy. So that's cool. That was easier than I thought. We'd proximity placement groups. Okay, I have some notes on this one as well. So you want your nodes in your cluster to be close together, so that in the Azure data center, so that they can talk to each other faster. That has a downside though, because if they're close together in one availability zone, then if that availability zone goes down, your whole cluster goes down. So that is a bit troublesome, but we'll look at creating a proximity placement group anyway, and then maybe we'll investigate availability zones later on and work out what we want to do with regards to those. So we'll create a new proximity placement group. Azure native compute. I think that's what we want. And we'll give this a nice name. Proximity placement group. Using my naming convention where I have the type, the location, and the environment followed by a dash, and then Pulumi adds some random stuff on the end so that we don't get duplicate names. Location. We'll stick that in the location that we need. Resource group. Name. We forgot to add tags to this. Tags. That doesn't have tags. Does this have tags? Yes, it does. And we'll stick that in there. And proximity placement group name and group type. I think the group name is just this. I don't know why we need to pass in a name there. I could be wrong. Let's just quickly test check the documentation here. The group name, sorry, that one. The name of the placement group. I'm gonna not set it to start with. We'll see if that was the right decision or not in a moment. And here we'll go with standard and ultra. I'm not sure what ultra means. Let's quickly Google it. Ultra. It's not going to tell us what they are they? For future use, ultra. So we don't use that. Standard is all good. And so then we need to pass this onto the node. So we go over here. We need to move this up before the cluster is made. Set the proximity placement group ID. Cool. So now we have a proximity placement group. Our cluster should have nodes that are created very close to each other. Let's try. Oh. Agent pool profile min count. Okay, so this is when we created. This is when we added. What did we add? We enabled auto scaling. So it didn't like. It wants min count, minimum number of nodes for auto scaling. So we just need to add that. I guess that should be a configuration setting. Where'd it go? Hold on. Have I just closed my tab? I think I have, haven't I? Here we go. No, we haven't. Autoscaler. Let's search for min count. If you need to enable and configure the cluster autoscaler on a node pool, use the enable autoscaler parameter and specify min count and max count. Okay, yes, we don't need to specify the count anymore. Or do we? Node count 1. Yeah, I think we need to change it to min count and max count. So we'll go here, max count. Do we already have that specified? No, we don't. So I'm going to create minimum count and maximum count. And we'll go find that. Maximum count gets the maximum number of nodes allowed in the cluster. Maximum is 100, I believe. And we'll do that. And this one gets the minimum number of nodes in the cluster. Minimum is 0. A minimum of 3 is recommended in production. There we go. And we'll go and implement that. Maximum 100 and minimum has to be 1, I guess. And we'll change this one to minimum. Minimum is allowed to be 0 and has to be 99, I guess, because the maximum is 100. Yep. And I think I'm going to change the naming here slightly. Maximum count, node maximum count. Maximum node count would make more sense. Maximum node count and minimum node count. And we'll change that here as well. Kubernetes maximum node count. And minimum. Maximum node count. Maximum can be 2 on development and minimum is 1. And over here we'll do something similar. In production, maximum node count, minimum is 3 because that's what's recommended by the Azure AKS guys. And we'll go with 5. We'll double it, 6. I've just realized we're using maximum pods and we're not using the word count. So maybe I could just use maximum nodes. That'll do. We'll come back to naming later. Naming is hard. And we'll fix this up as well. Minimum node count. Why didn't that work? Minimum. I can't spell. That worked. That worked. Add it right there. Add it right there. Cool. I'm going to comment out the proximity placement group for a moment. And we'll go back and try this again, just to make sure we're not going to break our cluster. I think this is key with Pulumi. Do a small update, run it using the CLI, do another small update, run it, do another small update, run it. Just because when you do too much, and I've done this before, something goes wrong and it stops working. How long have we been going for? For about half an hour. We'll just watch that for a second, and maybe we'll think about what we're going to do next as well. So upgrade the node image. There was something about ephemeral OSs. Not this one. Custom node configuration, configure AKS cluster. Yeah, this guy. So by default, Azure automatically replicates the operating system disk for a virtual machine to Azure storage to avoid data loss should the VM need to be reallocated to another host. However, since containers aren't designed to have local state persisted, this behavior offers limited value while providing some drawbacks, including slower node provisioning and higher read-write latency. Ephemeral disk OS disks are stored only on the host machine, just like temporary disk. This provides lower read-write latency along with faster node scaling and cluster upgrades. I think cluster upgrades in Azure are really slow. Instantiating new nodes, I should say, is really slow, I've heard. So ephemeral OS disks sounds like a good thing to do. Like the temporary disk, an ephemeral OS disk is included in the price of the virtual machine, so you incur no additional storage costs. That's good, it's cheaper. When a user does not explicitly request managed disks for the OS, AKS will default to ephemeral OS if possible for a given node pool configuration. When using ephemeral OS, the OS disk must fit in the VM cache. The sizes of VM cache are available in Azure documentation. Okay, so it tells you how big disk size needs to be. Using the default standard DS2 with the default OS disk size of 100 GB as an example, this VM size supports ephemeral OS but only has 86 GB of cache size. This configuration would default to managed disks if the user does not specify explicitly. If the user explicitly requested ephemeral OS, they would receive a validation error. Let's see. Node OS disk type ephemeral. So is there a setting here where I can say node OS disk type equals disk type dot managed or ephemeral? What is the default here? Come on, is this, how did this go? We got one updated, that's good. So that worked. OS disk type, here we go. Allowed values are ephemeral and managed. If unspecified, defaults to ephemeral. When the VM supports ephemeral OS and has a cache disk larger than the requested OS disk size, otherwise defaults to managed. May not be changed after creation. So that's a thing that you want to get right the first time round. And has a cache disk. I think ephemeral is the right default to have, to be honest. So I think leaving that on ephemeral makes sense, and I'm just gonna stick it there explicitly. And now we can also uncomment our proximity placement group and this line of code here as well, and see if we can run this again. Add proximity placement group, and we'll see if that gets updated with it. And we'll just comment that, grab that comment there, stick that in there. And also, what did we update here so far? I forgot to commit often. Oh, we have a slight typo here. There we go. Not sure what's going on there with the indentation. I should have used an amend. No, can I? Too late. Is this going to work? It's building the project now. Oh, we're going to get a new kube config. It's creating a new placement group, and plus minus means it's going to change the managed cluster and the maintenance configuration to replace. Oh, plus minus. It's going to totally drop the cluster and create it again. And we got an error. The virtual machine size has a cache size of 0 bytes and temporary disk size of, but the OS disk requires, I think we just didn't give it enough space. So what is that many bytes in gigabytes? $32. 32 gigabytes. So we'll go over here, change that to, we'll give it a bit extra, 35. Try that again. So that was interesting. We didn't have this ephemeral OS type set. So what it was doing is it looked at the OS disk size and it said it didn't have enough. So I think according to the documentation, it was defaulting to the managed disk for us because we didn't specify enough disk size, which is not good. We lost a bit of performance there, left it on the floor, but we caught that luckily. So I think being explicit there is a good thing with the ephemeral OS disk type. Let's see what it's going to do this time. So it's created the proximity placement group last time. This time it didn't have to create that, but it's going to drop the managed cluster and the maintenance configuration and recreate that. Creating replace. It's the first time I've seen that. Oh. No, didn't like it still. OS disk requires as a cache size of 0 bytes and a temporary disk size of that many bytes. But the OS disk requires that many bytes. Use a VM size with larger cache, larger temp disk. Am I missing something here? Enable node public IIP, OS config, node labels, OS SKU, pod subnet ID, scale set priority, spot max price. I don't see any other settings here that would... I have saved everything, haven't I? Let's try that again. Maybe I'll just set it to 100 and then I'll come back and look at the documentation to see what the lowest value I need to set this to is. Cache size of 0 bytes. That documentation was a bit... on existing clusters. The default node OS disk configuration uses 128 gig, which means you need a VM size that has a cache larger than 128 gig. The minimum size for AKS images is 30 gig. Node OS disk size. So they're not setting any values in here, in these commands, as an illustration for what we need to set there. That's interesting. Let's have a look at this. I'm using the B series. B2, what did I use? B2S. 2 CPUs, 8 gigabytes of temp storage. Oh, I wonder if that means that there's just not enough storage in that VM type. Has a cache size of 0 bytes and a temporary disk of that many bytes. So that's what that's saying there. Temp storage 8 gigabytes. Cache storage doesn't have cached storage. OS disk requires that much. Use a VM size with your larger cache, larger temp disk. Okay, so we can't use that size. So we need... the cost is going to go up here if we do this in development. So if we use the Azure pricing calculator, we can figure out what's going on here. So we want a virtual machine, and I'm going to get rid of that. I want a virtual machine. Are you going to add one? Here we go. So we're in, I think I chose Northern Europe. Linux, Ubuntu is fine, standard, tier, general purpose, B series. I had B2S, 8 gig temporary storage. So we had, let's switch this to pounds because I don't understand dollars. £24 per month with the B2S series, and then it wants me to go to 32 is maybe not enough, B4MS, and we've just gone to 99. So that's quite a bit more expensive, and it's going to blow my budget. So if at all possible, I think I'm gonna not use ephemeral storage locally in development, and then maybe use it in production. So that means that I need a configuration setting for OS disk type. OS disk type. Why can't it find that type? Gets the type of the disk used by the nodes. Ephemeral is cheaper and faster, but requires a VM size which supports, what is this? What was this bytes again? $32 gigabytes. Gigabytes of temporary storage. Cool. I'm gonna add that here. These config settings are complex. No getting around that. Ephemeral managed. Cool. And we'll take this, stick it in here as well. Public. And we'll stick this here. OS disk type, I can't spell ephemeral, so I'm gonna have to go back here and grab that. Ephemeral, no, we don't want ephemeral. We want ephemeral here in production, but in development, we're just gonna go with managed, and we need to plug that in as well. So we're gonna have to go configuration.os disk type. Save that, and then try to create that again. Oh, just, what did we add here? This should get us far. We should check the proximity placement group name in Azure as well. So where's my Azure portal tab? It's disappeared. So I'm just going to go to the Azure portal again. Really quick. Load it up. And do we have, there he is. Proximity placement group. Let's check out the name. The name looks good. No resources in this proximity placement group. That's because we're creating them still. That's fine. I have my tags. Type standard. Northern Europe. Properties. Nothing I can change here. No options required there. So that's all good. We're getting more and more resources popping up now in our cluster. What do we have here? Network security group, public IP address, proximity placement group, network watcher. It's all coming together. The value of parameter agent pool profile dot count is invalid. Oh yeah, I forgot to do that. Count equals the same as the minimum count. So we'll do that and set count to min count. Node count to the minimum count. Didn't I just, yeah, there we go. Took a second for it to take. And this should work now. So we have a cluster that has proper auto scaling, proper configuration setup. We've pretty much filled in every single property on our agent pool profile, apart from these ones, which we will come to. So we need to look at availability zones, encryption at host. I'm not sure what that is. Enable node public IP. So you can create private clusters. I think that's what that is. GPU instance profile, we're not going to touch that. Kubelet disk type, Linux OS config, I wonder what that is. Linux OS config. I don't know, we'll come on to that later. Node labels, yeah, so you can pre-apply labels and taints to your Kubernetes nodes. Orchestrator version, OS SKU, choose from Ubuntu and CBL Mariner for Linux OS type, not applicable to Windows OS type. I think Ubuntu is fine. I have what is CBL Mariner? Linux CBL Mariner. What is that? Linux OS for Azure 1P services and Edge appliances. So it's made by Microsoft, okay. It's an internal Linux distribution for Microsoft Cloud Infrastructure and Edge products. Yeah, I've never heard of it. I'll stick with Ubuntu, I think. Let's see, has that worked? Nope. Node resource group already exists. Node resource group already exists. Please provide a new one. At this point, I think I'm going to tear down my cluster and recreate it, because I think Pulumi is confused. So that's going to take some time. In the meantime, I will get that done. I'll make sure it works. Check that in, so that anyone watching you can check out in the description below the link to the repo with all the code in it, and you can follow along. Please do like and subscribe. It helps the channel out. And also don't forget, you can just ping me on Twitter at Rehan Said UK, or you can email me. There's a link to my email address in my blog as well. So check that out, and I'll see you in the next one.